Here we are in the second part of this pair on commercial types. I looked in the first one at the way in which these unprecedented, aggressive forms were actually invented and applied to type. This is going to be more technical. Here we are in the second part of this pair on commercial types. I looked in the first one at the way in which these unprecedented, aggressive forms were actually invented and applied to type. This is going to be more technical. For one thing, if you look at a title page of the early 19th century, it may well be an engraving. And here you see one of 1815. Those bigger capitals, great roads, England and Wales, might have been in a heavy fat face, but the copperplate engraver couldn't handle dense black areas, and so was obliged almost to open up the density, and in the case of England and Wales, invent some really rather delicate ornaments that would hold the ink. And this idea was transferred to conventional metal type. These are both from punches in the foundry of Figgins, but they're imitating the style of the copperplate engraver. An even more curious example of this handling of other technologies is seen here. In a way, you would think this couldn't be done in metal type. It's the sort of thing that a lithographer could do. That delicate line would be very difficult and tedious for a punch cutter to do. But a punch cutter did it. And there are the punches of that type, with a line running round the edge of the letter, which must have been extremely delicate work in steel. Another technical change was to find a way of making big, but also very, very beautifully drawn metal types. Sans pareil is a way of describing a matrix, which you see here, made up of two plates. There's a backing plate, and the outline of the letter is actually riveted onto it, which of course sounds easy, but in a letter like this, you see that very narrow strip, which is beautifully cut and riveted onto the background. But this meant you could have types inches high, which could never have been made in punches and struck into conventional matrices. Incredibly delicate work. And of course, when you have a simple letter like Figgins's sans serif of the 1820s, you might think it was a very suitable way of making the matrix for so simple a letter. Yes, up to a point it was, but what about the triangular counter to letter A that had to be separately made and riveted very, very precisely to the background of the lower part of the matrix? So there we are, technical advances, but also considerable technical problems. Nevertheless, if you look at a big poster like this one, there seems to be no doubt that the fat face of the eclipse, and probably also for the word printers, would have been produced with these sans pareil matrices. An alternative was, of course, just to cut the letter in wood and make a stereotype casting. And this was done by an intruder into the type founding scene. We don't know a lot about Pouchet, except that he insisted on keeping that accent on his name, and almost certainly he was an immigrant from revolutionary France, or his family was. This is his specimen of the 1820s, and many of the stereotypes that he sold were images. Here you've got a steam packet. This is what that big yellow poster was talking about. But he also did letters. Here are some letters for posters, which are very elaborate indeed, and we know how they were made. On the right you have a stereotype casting from a wood block, and there on the left is the way it looks. So that's one of the letters on the poster we've just seen. How they were cast isn't so easy to explain. This is a device invented by Henri Didot, who was in fact a very fine punch cutter, but his polyamar type was designed to either to cast about 200 types at once, or it would cast some of these large types. There's a more realistic view of the way it would look in action. Huge amount of metal being poured into the machine, and very sensibly these guards to cope with splashes. And this is one of Pouchet's types. We know it's cut on wood because the original wood blocks do survive at the St. Bride Library. But here is the way the stereotype casting would look. And here, for example, is in the top line here is the way they looked in the 1820s specimen of Pouchet. The black and white is relieved by this extraordinary ornament, clearly the work of a very, very skilled trade wood engraver. But it could have been improved by hand, and Ian Mortimer, who in 1991 made the great book of all the Pouchet ornamented letters, made this hand-coloured version. Frankly, one doubts if that was often done, but it was a way of attracting the attention of the public at whom these big letters were aimed. And so in the 1820s and 30s, these types would have had a certain appeal. They were overtaken by a whole new technology, the pantograph. Now this was a device for tracing a drawing, if you like. You could put a pencil in the bottom left-hand corner here and have a pattern which was followed by another part of the framework, and it would produce an image the same size or smaller or bigger. In this particular case, you have a pattern in the bottom left, a relief of the letter you want to reproduce. And up there in the top right, you have a rotating cutter, which is cutting into wood and driven by a power belt, which you can see in action there. And the result was a complete, accurate rendering of the original pattern in various sizes. Theoretically, these could all have been done from the same pattern. Clearly they weren't, but it gives you an idea of the revolution this made to the making of big letters. And some of the letters were very big indeed. So the 19th century townscape with its huge posters was made possible by the making of big wooden letter. By the way, the Pouchet stereotypes were very expensive, very difficult to make. And of course, if you dropped one, the delicate pattern would be the bit that hit the ground first and was ruined. Wood letter's tough. You can kick it around the office and it'll survive. And of course, you can play variations with colour. There's one big size. This is an American invention, I suppose, on the whole. In the United States, type metal was rare and expensive. There were a lot of trees. But here we've got a London maker of wood type called Bonwell, and in this image showing the workforce outside the factory, in the bottom left you've got a poster of a performer at a nearby music hall, and that name, Blondin, one suspects that's a two-colour piece of printing. This is the way it looks in Bonwell's specimen. They were so accurately made, these wood letters, that you could make a two-colour piece of printing. In fact, it calls itself here two-colour. In fact, if you look at an example, it is indeed printed in two colours, but the blue printed on the red comes out as black, so it's a kind of a three-colour job. In a way, this is typical of the product of a rotating cutter, which makes these curious scooped lines. In practice, of course, these very sharp corners are fake. I mean, these are not at the work of a rotating cutter at all, and there must have been a certain amount of hand work to make the corners. But even so, this is the part of the new townscape of the big cities. Rum, gin. So as a promotional medium, the wood letter shaped the typography in public of the 19th and indeed 20th centuries. Let's shift to something else, and that's the actual shape of letters. Nicolette Gray said that this was an abrupt and appalling change. The fat face had been rather broad and cheerful, if a bit aggressive, but this change to a compressed version, she finds, well, a change of mood. And in fact, it was a change of mood in another way. Here's a protest from one of the very elite unions, the London Society of Compositors, saying you're using thin fonts. And of course, the compositor setting type was paid by the length of line he set. If type became thinner, narrower, the compositor was being made to work putting more letters into the line than the broad fonts would give him. And you see the effect here, particularly that chapter heading. That letter C is much narrower than it would have been 30, 40 years before. The compositors had one way round that. If you're making us set more letters, we'll put more white space in between the words. And they did. This is a special case because, of course, it's for a book for children. But even so, you get this effect in many 19th century pieces of normal printing. The spaces get a lot wider to compensate for the narrow type. The effect of this narrowing of Roman is echoed in the first related bold, a type that was called Clarendon, and it was thought so original that the founder registered it as a design. Here's a promotional note about it. The bold form of Clarendon matches the narrow Roman, and that's a great advantage to the look of the page. Also, it's being suggested here. Of course, it may have been registered as a design, but it was, of course, stolen. So piracy was how it was dealt with by rival type foundries. But of course, the related bold became a standard alternative form of new designs as they came onto the market. In something like this Latin grammar, but also, of course, for new forms of printing like railway timetables, or indeed time-honoured ones like dictionaries. And as a kind of paradox, when the Fan Street Foundry introduced an extended version, they were simply bringing the design back to the proportion of what would have been a normal Roman type earlier on. And so the Clarendon with its bracketed serifs became a new and a really very finely handled form of 19th century type. Another curiosity too, what were news fonts? Well, there is one letter that shows you how rough the making of newspapers was on type. Kerned letter F was one of the things that would be stamped and broken if kerned letters were kept for printing newspapers. And so letter F was made without a kern. It's slightly absurd in this example because the FI ligature and the FL ligature, which you see here, were made because you could not put a kerned F in front of a letter I with its dot. Well, you could have done with this kernless version. So here's a rather absurd paradox. But of course that kernless F was to facilitate something that almost destroyed type founders as producers of single types, the liner type. Type founders didn't give up easily. This is a piece of printing at the University Press at Oxford in the 1880s. And as you can see, the F is kernless. They could not bear to give up the beautifully kerned F of the italic form. So one assumes that this is from single type, preserving the kerned form. Another technical matter, purely technical. Lithographers drawing on the stone could make letters do things that a letterpress printer with his square type could never have done. Setting type in beautiful curves like this. You couldn't do it with square type, could you? Well, you could. And here is an example of type made by a conventional type founder in France, Derrier. How did he do it? And his trade card shows that he could. This is all conventional type, set in curves. How did he do it? Well, here's the metal furniture in these beautiful round and oval forms that could be made for setting square type in curves and circles. Another technical problem. A lithographer could make these beautiful, incredibly delicate designs with their fine lines. Could a letterpress printer or a normal punch cutter in steel do that? Must have done, because these are both examples of normal printing type. The idea of getting a conventional punch cutter to do it hardly bears thinking of. But another bit of new technology, the electrotype, enabled someone to make a letter not in steel but in soft type metal, and then to make a version of it by producing a electrotype which is deposited copper, and that could be used not only to make a version of much more delicate punches cut in soft metal, but you could actually take an existing type and steal the design. So this is a new world of sophisticated technology and engineering coming into the making of type. That's an example of the early 20th century from a German foundry, showing how the making of matrices, which had been a matter of skilled handwork, became very much a matter of microengineering. The actual making of type could be dealt with too. Here is a hand mould. Those two parts have got to be brought together and the matrix put in place so that the metal can be poured in by hand. Here's a machine that'll do it all. The two halves of the mould are fixed to separate arms. Behind them is a pot of molten metal with a gas flame underneath it. That spring operates a pump. Everything is programmed, you could say, from that axis on which are several cams that operate a sequence of actions, bringing the two halves of the mould together and the matrix behind them, and then triggering that pump to squirt hot metal into the closed mould, which then opens up and lets the type come down that chute to the left. Well, that's the new world of 20th century type founding. Here's a factory that the Caslon foundry made for itself in 1902, and you have a row of what look like about 40, 50 separate machines driven by power, all producing type automatically. The only handwork needed is provided by the labour on the right, the young women who are tidying up the result of this mechanical production. But you didn't even have to do that. The great Bart casting machine of the United States of the same date did all the operations, casting the type, cleaning it up, and they could handle huge bodies too, 96, 120 points even. Even the pantograph was brought into use not only for making big and rather crude wood letter, but here is a type founder called Lynn Boyd Benton, who harnessed the idea of the pantograph. There is the pattern of a piece of type halfway down, and the tracer is linked to a power drill which can reproduce that pattern on an infinitely more small scale, 10 point, 6 point, and less. So the mechanical production of punches became possible at the end of the 19th century. The result was devastating. The limitless production of accurately made punches opened up the market to a machine which carried a stock of hundreds of mattresses, which were brought together and made a casting of a line of type, the linotype. And there is its product up at the top left, the single line, which could then be made up into particularly newspapers. And straight away it took away the most lucrative part of the type founder's product, the tons of single types, which could now be set from a keyboard on a machine. Well, the result was devastating. Almost all the American type founders, 23 of them, were merged into a single operation in New Jersey, just across from New York City, to make the American Type Founders Company. And for a while that did save the market for type founders. The linotype could not make big types, so that part of the market, the making of display type above about 18 or 24 point, remained open for a long time to the founders of the 20th century. What they had to do was promote the product. And these are some of the best-selling typefaces that Morris Fuller Benton, the son of L.B. Benton, made as in his position of type director at the American Type Founders. At the bottom you've got the name of some historical models, and we'll come back to them eventually. But in the meantime, the great bestseller, Cheltenham, was a design that could be exploited in hitherto unexplored ways. The idea of the type family. At the top is Cheltenham Old Style, but then the related bold could be added, and then, as you see, bold condensed, wide, and an inline version or an outline version, and so on. And printers could be persuaded to buy this stuff in the same family by relentless direct mail. Well, there we are. Type founding, in a sense, was saved for the 20th century by stepping sideways into the marketing of big type for commercial publicity. And so Cheltenham became what the publicity office of American Type Founders called it. So we'll leave that one there.